Hello everyone. Uh, this is a continuation of the previous lecture where now I will be discussing a question based on the fact that how a matrix can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. This is the last expression which we did in the previous lecture. So now what we have to do is that we have to express the matrix which is given over here as a sum of symmetric and skew symmetric. Now, we have just explored in the previous lecture that this portion was my symmetric portion and this one is my skew symmetric portion. So for that, let us first of all calculate the transpose. What is it? The rows become my column, right? So this is my B transpose. Now let us just find these two values over here, B plus of B dash, B minus of B dash. Now, since we have just calculated the B transpose, we will just find each of these values, the symmetric and skew-symmetric part. So for the symmetric part, we need to calculate B plus B dash, which is nothing but my matrix B, and the B dash, which we have just calculated above. Now we know that in addition, what we do, we simply add the corresponding terms, and we just calculate the sum as the usual arithmetic addition. So this is the final result of my B plus B dash. Now we have calculated for the symmetric part. Now what is my symmetric part? It is my B minus of B dash. So in a similar way, we will just write the matrix B. This is my matrix B and this is my B dash. And in a similar way, we will just subtract the corresponding elements and this is my resultant. So the next step is that we need to check whether if I scalar multiply my symmetric part with half and add the minus B minus of B dash, will it give back my matrix B? If this is equal to B, then we can simply say that B can be expressed as the sum of symmetric and skew symmetric. So let us just write the expression. Just by simply substituting my symmetric and skew symmetric part, we can now just calculate it. We will just scalar multiply first of all. And in my previous lectures, we know how to scalar multiply, like we just multiply the value which is half over here with each of the values in my matrix. Now, after you multiply it, we will just add the sum. And if you will observe, this is my final resultant, which is nothing but my matrix B. So what we have just calculated is that this value comes out to be my matrix B again. So this shows that my matrix B can be expressed as the sum of a symmetric part and a skew symmetric part. So this is how you solve the question based on this. Now that we have shown that the matrix B can be expressed as the sum of these two, the last step is that we need to check whether the sum B plus B dash, and since this is the resultant matrix, is this a symmetric matrix or not? And in the same way, I need to check whether my B minus B dash is skew symmetric. So just to confirm that this portion is symmetric, we will just find the transpose of this matrix. If you don't know how to find the transpose, just go through my previous lecture, transpose and its properties, that is part 4. So you can see that this is nothing but my B plus B dash. Hence, this portion is my symmetric. It is proved. Now, what about this B minus of B dash dash? Again, we will find the transpose of this matrix. 0 minus 1 and minus 5, 1, 0, 6, 5 minus 6 and 0. Now, you can observe that this is nothing but B or B minus of B dash with a negative sign. Hence, this is my skew symmetric. So after proving that this can be expressed as my sum of symmetric and skew symmetric, the last part is to just check whether the transpose is giving out to be symmetric or skew symmetric. So this is it for today. Thank you.